what I'd like to talk about today is basically building RESTful services with XQuery and XRX. Chances are some of these terms, especially the XRX term, is one that may be unfamiliar to you. The idea here is, first of all, that when we're talking about RESTful services, we're talking about not necessarily a hugely different paradigm, but simply an evolution of one of the paradigms that has been going on for some time now. And so when I'm talking about this, I want you to keep in mind that what I'm talking about really isn't new. It's just simply a new way of looking at what we've already built and kind of thinking about it more from an architectural standpoint than anything. All right, so there's been a lot of discussion about services, web services, SOA, fill in the blank. We're definitely moving into a services-oriented mode. When you talk about RESTful services, the term itself has a somewhat different connotation than when you start thinking about web services or specifically RPC-specific services. And again, it's not so much a question of how you deal with this information, or it's not so much a question of how you reference things, but how you think about them. When you're talking about RESTful services, what you're basically talking about is an emphasis on collections of resources. Now, this is a novel concept. Most of the time, when you're working with SOA, or when you're working with RPC, web-based RPCs, you're tending to think about services as, I'm making a request for a particular function, and I want the results of that particular function. What you're generally not thinking about is, I'm dealing with collections of resources. I'm dealing with, I'll kind of give you into a little bit more detail there as to what I mean by both collections and resources. But what you're typically talking about is the idea of a resource as a block of information or as an object that you can basically reference from the web. In a way, one of the whole ideas behind RESTful services is basically you're treating the web itself as a giant database. And especially once you start integrating that with XML databases or similar type structures, you can actually get a fair amount of leverage working at it. So when you're talking about RESTful services, there's an emphasis on collections, there's an emphasis on resource. You're using URLs to make those resources addressable. If it's not addressable in some way, then you can't get to those resources on the web, therefore they don't exist. The primary operations that you're dealing with focus on publishing, web publishing in particular. Now, when I'm talking about publishing, I'm talking about CRUD-based operations, create, read, update, delete type operations. Those are primal to the web. You're used to, especially the read type, but all of the other operations that exist that I've just covered there are similarly operations that are called that are focused specifically on publishing. If you think in terms of those publishing models, rather than thinking about I want to be able to build a more substantial model, what it does is it simplifies the underlying resources and simplifies the APIs that you're working with. RESTful services are generally asynchronous. That is to say, when you're working with a RESTful service, you're not usually getting, especially when you're doing things like posts or puts, you're generally not talking about operations that are going to be synchronous. You're going to make a post, for example. That's going to cause a chain reaction at some point, but it's something that you don't necessarily see. All you need to know is basically where the results come back. Finally, when we're talking about resources, and this is something that specifically deals with XRX, you're talking about the resources that are represented internally in XML. And I want to kind of waffle a little bit on that one. When you're talking about this, it doesn't necessarily mean that you're dealing with XML content specifically. What it does mean is that you have some mechanism for, especially for XRX services, that can treat the data that you're dealing with in an XML-like fashion. In that way, you can basically abstract that information and work with it in a way that doesn't depend upon where the information comes from, what doesn't depend upon having a certain type of data reader, and so forth and so on. Other applications have similar models. For example, Ruby with the active record has kind of the similar model that's going on. But essentially what you're trying to do in this model is say, at least on the back end, our resources are represented internally in XML. So when I talk about a resource, let's get into a little bit more definition here. A resource is an abstract entity. A resource doesn't actually have when you talk about a resource, you're not actually talking about a specific block of code. You're talking about an abstraction. But that abstraction has properties, it has structure, it has identity. The notion of properties obviously are going to be things like elements within an XML object, or for example, if I have a document, the properties of that document are going to be its head, its body, sub-elements there. If I'm talking about data or data structures, and those data structures may be something like, let's say I have a character from a role-playing game, as I'll use an example here. That character can basically be represented as a name, a species, or whatever, but each of these pieces are properties. The structure basically indicates how those properties are put together. The identity basically means that you have some mechanism, usually a URL, that can be used to be able to point to that particular piece. Now, a resource may have more than one identity, but there is at least one identity that is available for working with that resource. As I said before, if a resource doesn't have an address in the system, it doesn't exist. So when you're talking about resources, you're talking about mechanisms or things that are essentially addressable. Resources finally have an implicit schema. There is a structure that you can deal with, that you can reference. It may not necessarily actually exist, but it can be generated as need be. So when I'm talking about resources, you hear the term REST a lot, but REST is also a term that tends to get overused in a lot of different concepts, and I think people tend to use it essentially anytime they mean I'm using GET, an HTTP GET. It's not quite the case. When you're talking about resources, you're basically saying, if I have if I have a particular resource out there, I can't ever actually get that resource directly. Okay. If I have a book, I can't actually get the book itself directly over the internet. What I can get is a representation of that book. And that representation can vary pretty dramatically depending upon what kind of format that I'm wanting that particular book in. If I say I want a representation of that book in PDF, then what will get sent to me is a stream of PDF binary bits. If I'm wanting that representation as an XML file, well, here's an XML resource. If I'm wanting that representation as some other entity, that can be done. But the important thing is that when I'm dealing with that resource, I'm only dealing with that resource at one move. I'm only dealing with the representation of that resource at any given time. Now, that time aspect is another interesting point, because when you're talking about time, there are a lot of resources that are fundamentally time-driven. A blog, for instance, is a resource that is time-driven. If I point to a particular blog, then what I'm going to get back is going to vary depending upon how recently someone has published to that blog. The blog itself is a resource. It's a resource that's time dependent. If I have a weather forecast, similarly, that resource is going to be time dependent. It's going to be dependent upon some particular parameters that say, okay, well, today you're going to get a weather report that's going to indicate what's happening in the next 24 hours, next 48 hours, or so forth. But those are always going to be updating. Therefore, when you're talking about a resource, you have to understand that there is that time-dependent functionality. And that time dependency is just one form of a general query dependency, which is built into the system, or which is kind of fundamental to the nature of resources on the web. When we're talking about these, when we're grabbing these resources, we're talking about transferring the state of that resource at any given time, transferring the state of the resource via a representation. Representational state transfer is what we mean by REST. The term was basically put forth by Roy Fielding about 10 years ago as part of his dissertation, and it's really become fundamental to the way that we work with the web today. Here's where things kind of break from the beginning. When you talk about REST, you really need to understand that REST is also built around the notion of collections. A collection is a list or queue of resources that are related in some manner. This is a little novel concept. You know, we don't normally think about collections in the web, but when you stop and think about the fact that more and more data-centric documents are moving onto the web, and those data-centric documents essentially can be thought of as, here is a collection of a certain type of document. The collection doesn't necessarily need to be physical. That's to say that I can have a collection without that collection necessarily simply being files in a folder. That's one particular organization scheme that can be used, but it's not the only one. I can say I would like a collection based upon what is the, I need to get all blogs that were produced from this date to this date. I want to get a collection consisting of all characters that are of this particular type. I want to have a collection that consists of all airplane specifications, S1000D specifications, or specification instances, specification documents that are currently in our queue. The idea here, however, is that you're talking about a list or a sequence of resources. A collection is also a resource. A collection can be assigned an address, just as individual items can. Again, the idea that we have most readily about that is the notion of a blog. Now, when you're talking about a blog, what you're actually talking about is essentially an entire sequence of articles that are published to the web. Now, when we get that back as an RSS or an Atom feed. But that RSS or an Atom feed is basically nothing but a representation of the blog itself. The address of that collection is ultimately a RESTful service. Now this is where I wish I could have a little bit more feedback from the audience on that. Let's see, I'm going to have to... okay. Yeah, the address itself is basically a RESTful service. So when you're talking about such an address, hold on just a second. All right. Okay,
are you trying to find the chat window?
Yeah, trying to find the chat window myself. Can anyone else see the chat window, or is that hidden?
I can see it. When you're sharing your desktop, you should have a little, looks like it's hidden on yours. It's grayed out, but you can probably see it, right?
Right.
Okay.
Okay.
And there have been a few comments, like Rick just said, I think Rick has a sense of humor. Atom is only a piece of the rest. It usually doesn't contain the whole post. And
yes,
okay.
I will agree with that. And there's another point I'll get into when I get into Atom specifically.
Okay. Okay. So yes, you should be able to float the chat window over your window, but it does block out some of your slides. Yeah, okay. The buttons on the lower right-hand side, if you're on a PC, if you're on a Mac, there's not a button, unfortunately.
Okay. It looks like my system is frozen up here. Okay, so I'm going to do a reboot.
Well, no. Here's what I'll do. Let me take it away from you and turn it back over to you, and that should be okay. Or well,
okay,
go ahead and
do
the reboot.
Actually, I'll continue on the audio. Let me just do a reboot on the video here.
Okay.
Okay. So let me actually address that. And it does look like I'm done. So I hope I didn't cause problems there. The idea here, when you're talking about Atom as not a complete collection, again, this is actually gets back to the fundamental notion of what we mean by a representation of a resource. Okay, obviously, when you're looking at the resource itself, that resource is basically a fairly abstract object. It's not something that you can directly point to and say, here is a single document that represents this entire set of all the blogs and posts that we've ever done in the last 10 years. Instead, the representation basically gives you just enough information to do several things. It gives you enough information to basically tell you where those resources are. It gives you the information to tell you usually a little bit of a summary, just enough of a summary to basically tell you, is this something that is immediately relevant to your needs? It usually gives you title and other aspects of that particular both the blogs and the individual entries within that blog. It can contain categorization information, and it can contain typically publishing information. When was this published? When was it most recently updated? Things like that. But this is a representation of each of the particular entries within a representation of the entire blog itself. It's certainly not the only one. I can have any number of different representations, but
hey, Kurt?
Yes.
Oh, sorry. I wanted to explain to the attendees what happened. Kurt just his computer froze, so he's logged out and he's going to log back in. So yes, something did happen. So.
Yes. Okay. Can people still hear me?
Oh yeah, we can hear you fine, and we have the event center window. We're just waiting for you to join again. No problem. This happens occasionally.
Yeah.
So keep going.
All right. So let me, after all that, I basically now we go through this long process, so maybe about 3 more minutes. Okay. So in essence, what that means, once we have this notion of REST and RESTful services, the second aspect that you run into, and I'm actually going to pull up my slides from my own reference just to make sure I'm not. Actually, here's a good point. Why don't you start fielding me some additional questions, and once I get back up, I'll get back.
Okay, and you know that you need to join the window again. Join the meeting again.
I'm still waiting for the everything to log on.
Okay, so Kurt says that he'll field any questions.
I quite planned on breaking this early in the process, but so are there any questions out there? I can't see them. I'll have to get them from you.
Yes, here's one. Can you explain how a collection is a service?
All right. A collection isn't a service. The address is a service. And this begins to get a little bit of Zen. The collection is basically just a sequence of resources. The service is basically a point on the web that you can basically apply just as you can with any other type of web service. Here are a set of operations that I can apply on that particular service to be able to get a certain result back. So in that respect, RESTful services are still services in the broader definition. When you talk about a service, let me give you a simple example. An index page. When you go and say, I'm wanting to point to a particular folder on a directory, what you get back if you have that privilege set, and there's always a question of privilege access in there. But what you get back as part of that process is basically a list, and usually it's just a list. You don't get a tree or anything like that. You just get a list of all of the particular resources that happen to be in that file. Well, that is in fact a RESTful service. That's a very primitive one, a very early one. But it is still a service in that you're basically retrieving back a set of content that indicates all of the available all of the available resources that happen to be within this collection. It's also associated with a particular context, in this case a particular address. If you go in and press or click on one of the links and it happens to be a folder, then it retrieves another particular collection as a service. Now, in some respects, this sounds like it's not very different from the way that we do things, and actually it isn't. One of the key ideas behind REST is not, hey, here's a whole new way of doing things. It's, hey, here's an old way of doing things that we've largely forgotten because we've become so fixated upon making commands and doing RPCs and building things along those lines. So when you're talking about this, there are other aspects there as well that I think are important. Okay, I'm actually back to my slides now. Let me pull up Mozilla. I hate rebooting. It always takes so long. Let's see, where am I? So I just want to make sure. So we're talking collections. F5. I want to kill that. 1. Okay. So anyway, let me get back a second. I'm actually now back up on my end, so I'll be back up on your end here in just a second.
Okay, good. Yeah, Donald was pointing out that you're on the 5th slide, and I think we were having some other questions about services and.
All right, just fire them away, and
okay, so. Let me go back because, let's see, you were talking about whether a collection is a service, and then one person asked, so the address of a blog is a RESTful service that is provided by a standard web server? And,
yes.
Okay, and and then another person asked, if I can understand the question, is the business service that deals with database, is it I think this person's asking, is it a service or a collection?
Okay, now that is a little bit different, and let me kind of.
If it's not the right time to jump into the answer to that.
Yeah, let me hold on that one for just a little bit. The answer is sort of.
Okay, that's a great answer.
Unfortunately, it's let's see if I can pull up everything. O'Reilly, what the?
Yeah, you just need to get back in the meeting so we can see your slides.
Yeah, that'd be nice. And I apologize to everyone, and I'm kind of at the mercy right now of Vista, which is kind of a scary thought. Okay, so now I'm pulling everything up. Now, you don't realize how complex the process this is, basically.
Are you talking about joining the meeting, WebEx?
Yeah, I'm about to do that.
Okay.
So, all right, so let's see. Here's our link to that.
These computer things.
Computers. Building RESTful Services, yes. We're due by 30 minutes now. Now it's... All right. So I actually have the link up. It's coming up. There we go.
I think Kurt is talking to himself at the moment. So.
Yes, I am talking to myself, and it's glorious. Okay, so let me give you some examples of collections, and I'll get back to where those are services. And I'll pull this up, but some examples of collections include things like invoices, medical records, resumes, job listings, library catalogs, SEC filings, income tax statements, aircraft specification. The list goes on and on and on. Each of those things can basically be treated in a RESTful manner in terms of being able to work with them, in terms of being able to edit them, in terms of being able to query them, and so forth and so on. Okay, so let's join back in. There is that. Hold on a second. Okay, so join event now as panelist. Okay. Event in progress. Wow, we're getting closer.
Yep, we're almost here.
All right. I'm not sure why this died.
Is it freezing on you?
No, it didn't freeze. Wait, this is coming up. There we go.
Oh, there you are. Okay, I'm going to make you the presenter again.
Okay.
And you can go ahead and share your desktop.
All right, so now we get to share the desktop that's been scattered to hither and yon. Okay, so I'm going to actually pull up my chats just a second. Let's hold it down here if I need it. Okay, so can everyone see that now?
Yes, we can.
Okay, so
I mean, I can.
when I'm talking, okay, everyone else is basically out of luck then. Now, one of the concepts that I want to deal with here is the notion of virtual collection review. Views are obviously things that, if you're familiar with databases at all, you're probably familiar with working with views via databases. A view is a virtual collection is basically temporarily constructed from existing resource collections via XQuery or other processing language. When you're talking about this, what this basically means is that you can actually have physical collections. Now, this gets a little flaky because a physical collection is still basically just a collection of data resources. But you can also have collections that basically consist of aggregates of other resources that are combined together in a certain way. So, from the standpoint of the client, there really should be no difference between a real and a virtual resource. So, for example, let me kind of step back a second. A good example that I can think of is something like a medical record. Now, a medical record is actually a very complex piece of work. There are literally, for any given piece, or for any given record, you're talking about everything from here's encounter records with your physicians, here is your insurance invoices and your insurance statements out to your various providers. There is lab results. There are things along those lines, each of which are organized in a certain specific hierarchy. In point of fact, what you can actually think of when you're talking about such a medical record is that it is not a single collection, but it is in fact a number of related collections, each of which internally are linked in some manner to one another. Now, from your standpoint, chances are pretty good that if you say, I want to get access to my medical record, you're not wanting to get an entire dump of everything that you possibly have in XML or in whatever other representation that you're wanting. What you're wanting to get is a view. I want to get a view showing my doctor visits. Those doctor visits themselves can be thought of as being collections. But they're not necessarily real collections. They're basically collections that you fabricate as part of some underlying process. It actually turns out that it's easier even when dealing with regular physical entries in an XML database, for instance. It's actually easier to put together some kind of a layer so that you can even treat those physical entities as being the same as your virtual collections. So when I'm talking about these systems, I'm actually going to go in and say, even when you're addressing your physical pieces, chances are that the information is not going to be in a format that is necessarily going to be relevant or meaningful to you. So what you're wanting is to have some kind of a virtual collection that will abstract that process out. Okay, so when you're talking about a collection, representing collections, a collection can be represented as a container holding one or more entries. So I talked before, and we mentioned some things about such as Atom. provide one particularly useful such representation. Now keep in mind, what is Atom? Atom basically consists of here is a feed block, and then here is a series of entry blocks. Each entry, in turn, is important from two standpoints. One standpoint is that it provides some physical relevant information to you about, here's a title, here's the publishing information. But the other, and perhaps more important piece, is it contains a link. So in many ways, when you're talking about resources, you're also talking about mechanisms to be able to link to other different representations of that same resource. So I can think of an entry as being one representation of, say, a blog. But I can also think of the URL, or the web page that comes when I click on that as being another representation of that particular blog page or blog entry. They're just simply different representations that we're dealing with. Moreover, because of the power of XML as a mechanism for doing transformations, you can basically work different forms and different presentations. You can give different XML outputs. You can give JSON outputs. You can create, here's SQL blocks for output. You can say, I'm going to turn this into a PDF and render it that way. All of those things are possible because they're simply different mechanisms for doing representations of collections. Okay, so when you talk about REST verbs, you talk about standard SOA. SOAP based SOA, and you have the potential of literally thousands of different APIs, tens of thousands, even millions of APIs. REST is simple. REST basically has 5 verbs. Get, which will retrieve either a collection of a resource or the resource itself. Post, which lets you add a resource to a collection. Now this is a very subtle point, and I'll get into it in a little more detail. Put replaces an existing resource with another. Delete removes a resource from a collection. And head retrieves a summary about the collection. I'm going to get into those in a little bit. I actually probably need to move that around a bit. By the way, just for reference, I will be making these slides available along with the source code for the examples that I'll be giving in just a bit. So those will probably be available, I'm guessing, by Friday at the outside as part of an article on O'Reilly.com. Okay, so jumping back into this. When we're talking about REST, this is much of the section and all the examples are basically about REST and XQuery. XQuery is a language that was finalized in February of 2007. There are additional specifications, including an XQuery update facility, which I believe are either in candidate recommendation status or are. I don't think XQuery is actually fully realized yet. I'll have to go back and check to make sure. But anyway, XQuery is definitely a language that I think has a lot of potential. It can be a bit of a pain to work with sometimes, but it is, like SQL, it is a mechanism that you want to learn if you're ever going to be dealing with representational or RESTful data. So REST is useful for real collections, but an ordinary REST typically doesn't provide a lot of processing mechanism. When you talk about here is a simple RESTful web server. Typically, all of that will do is basically say, here's the article, or let's say here's your invoice. Here's a way to post an invoice and things like that. It doesn't do any additional processing. However, most services, especially if you're posting, say, an invoice, you want to get paid. You want to have that invoice be processed in some manner. So you have to have some mechanism to be able to use these RESTful concepts and at the same time to be able to do more with these RESTful concepts than simply deal with publishing. Publishing is an important side of it. It's an important interface. But something usually has to be done at the other end. XQuery is actually very well suited for this. It's suited for a number of reasons. One, it's good way of being able to deal with XML data, which means anytime that you're dealing with data in an abstract format, not dealing with data in a database, but here's data coming from a stream, here's data being pulled from one or more databases. Or here's data that I'm needing to present to a widget. It's a good intermediate format. It's a good format for being able to do cross-translation. XQuery also provides an abstraction layer to databases themselves. So if I have an XQuery engine, it doesn't really matter what the database is on the other side, more or less. And there's some efficiency matters, but those are basically vendor dependent. What does matter is basically that I can address that information in a manner that is structured or can be represented in terms of XML. It also means that I can start treating other data streams such as syndication feeds, such as SOAP blocks, such as XMMP messages, such as really any kind of XML messaging that is going on within the cloud as being a potential database. Now, this is personally one of the coolest aspects I like about XQuery. Because you're dealing with it as a potential database, it means that it doesn't really matter what that data source is. It could be a file, it could be a process, it could be a stream, it could be a database render, any kind of things. Because you're dealing with it on that abstract level, it doesn't matter. Okay, so RESTful Services and XRX. What is XRX? I've talked about it some on O'Reilly. So let's go back a second. So what is XRX? XRX is XQuery, REST, and XForms. XRX is a form of RESTful services. There are others. You can do the RESTful services architecture without having to do XML. But XML is particularly well suited for that particular use. XML is used for transport. So you can use either plain old XML or POX, or you can use Atom or some other syndication feed, or you can use SOAP, or you can use whatever. It really doesn't matter what the transport mechanism is, but you can use it as a transport language. XQuery is used for the server processing. REST interfaces are employed almost exclusively. That's to say that from the standpoint of where your operations are going, you're basically dealing with publishing operations only, and then everything else becomes essentially a pipeline working off of those publishing interfaces. The client accepts, when I talk about the third X or the second X, XForms, what that basically means is the client accepts an XML object, can make changes that can transport that XML object back to the server. XForms is perhaps the best exponent of this particular approach. In other words, what that means is that on the server I have XML. It's a representation of state. It gets sent to the client. The client works with that XML as the representation of state, makes corresponding changes to it while still keeping that state consistent. That's one of the benefits of XForms. And once you have made the necessary modifications, then you send that blob in toto back to the server. So this is a little bit different than what you're dealing with when you're talking about normal name-value pair types of operations. You can use a name-value system. In fact, I utilize it to some extent, even within the examples I've got. But you don't necessarily have to. And more to the point, if you're using XML on the client, it gives you much more leverage and capability than you would have otherwise. So let me talk a little bit about XQuery. I've talked some about this, but it's a SQL-like language for querying and manipulating collections. It can be used to update collections with the XQuery update facility. It can be extended via modules written in any language, including XQuery itself. Now, this is probably the coolest aspect I like about XQuery, is that you can modularize it. You can create libraries of modules, and because you can create libraries of modules, you can effectively create an OOP-like environment within your XML space. or within your XQuery space. You can also extend it with other terms. So for instance, I can basically say, I'm going to create a Java-based library that will give me these functions. Most of those extensions that you're talking about are actually extensions to XPath. But XQuery can be used as one mechanism for extending the XPath2. It provides an abstraction layer, and it can work by pulling data from multiple streams. There are a few disadvantages. The standard is still relatively new. There are a fair number of XQuery developers, but not a huge amount. So if you're looking at new projects, it may not necessarily be the most efficient mechanism for being able to get a lot of got a lot of people up and running quickly on this particular type of projects. That's changing, especially because you're seeing more and more XML databases being utilized. XML databases and XQuery kind of go hand in hand. So as XML databases become more heavily utilized, expect XQuery to be more utilized as well. It does require a very deep understanding of XPath to do more sophisticated stuff. This is a limitation which I know a lot of people don't like XPath. If you're not happy with XPath, then it's probably not the career choice or language choice for you. XQuery 1.0 support in tools and databases is becoming standard but not universal. XQuery took a lot of time to bake. And because it took a lot of time to bake, there was a long period of time in there where companies were basically standardizing on particular XQuery implementations or XQuery working drafts. And not all companies have actually gotten to the point where their products are up to speed with the 1.0 spec. I'd say that's probably not, the biggest holdout I can think of right now is Microsoft, and even they, I believe, are moving towards that, towards the 1.0 implementation relatively soon. XQuery support them. Okay.
Sorry, Kurt. So Rick is mentioning XPath 2.
Okay, yes. In what context?
I don't know, just that.
Okay, let me talk very briefly about XPath 2. I don't want to get too far out from it. XPath 2 is not XPath 1. XPath 2 basically started out as a process in after XSLT 1.0 came out. There was a move towards essentially extending it because there were some limitations that were fairly intrinsic, not only to the XSLT model, but even down to the XPath level. And so when XSLT 2 came out, or when XSLT 1 came out, there was a movement towards putting together a group called the EXSLT.org group, which basically built some extensions. This was actually going to be in XSLT 1.1, which never really happened because the realization was made within the W3C that XPath itself needed to be changed at a fairly critical level, at a fairly fundamental level, in order to be able to facilitate the changes that were made. Those changes took a while, and they involve a number of different areas, one of the biggest of which includes the move towards sequences rather than node sets. Once you move to sequences, it basically gives you the capability of doing things like creating interim XML structures and working with those interim XML structures in a way that you don't need to provide an extension for it. It also expanded extensively the extension mechanisms, the set of libraries that you had available for processing the sequences and for doing other processing. All the date routines, 1001 plus date and time routines. I don't remember exactly how many, but there were a bunch of them. Other things along those lines. So XPath 2 is a fairly different beast than XPath 1. It's much more powerful. In some respects, I think it is much cleaner a language than XPath1 was. But XQuery is based on XPath2. XSLT2 is based upon XPath2. XPath2 is now part of the XForms 1.1 recommended set. That's to say that you can actually incorporate XPath2 into XForms-based system. It's not seen a lot on clients yet, but you're beginning to see, especially in XML databases, things like Saxon, elsewhere, you're beginning to see that adoption of the XPath2 spec. So, again, I'm not sure it's necessarily a disadvantage. It's just that it's probably the biggest factor in getting new changes on XQuery. All right, so let me pick up XML databases and REST. XML databases support collections natively. This should be a no-brainer. When you're talking about XML databases, what you're talking about is basically collections. Most contemporary XML databases include XQuery supports, and many support REST interfaces in one mechanism or another. XML databases are optimized for document-oriented resources, typical of most business needs. We're moving to an age of super data. We're moving to an age where when we're talking about data structures, these data structures may have hundreds or thousands or even tens of thousands of elements in multiple subordinate trees and in some cases in related entities and the like. So what ends up happening is that in many ways our need to be able to work with that structured data outweighs the benefits that you have with the relational data model. The relational data model is very powerful and very useful for a lot of things, but it does impose upon the people doing the queries a very deep understanding of the interrelationships that exist that can be very, very daunting for people working with data. If you can basically move to a model where you have those structures already implicitly developed and can generate them and output them, this gives you much more advantage to be able to work with information at a higher level. This is where XML databases really come into their own, and because we're moving to a point where more and more of our data needs are moving into that direction, XML databases are definitely taking off. Many XML databases also support pipelines. Now, what do I mean by pipelines? Do I have to cover pipelines? Okay, I'll come back to that if I don't. A pipeline is basically a set of, or a sequence, or in some cases a tree of operations that a given set of XML will be pushed into. You can think of it as one of those Rube Goldberg type machines where you push a marble down a thing, and by the end of it, you've basically set houses on fires, you've caught cats, you've done all kinds of things. This is the power of pipelines, in that you can basically say, here is an abstraction that still lets me work with this XML so that I don't have to necessarily code it with XQuery directly. I can basically move that query into much more manageable chunks, and those chunks don't necessarily have to be clean. The examples I'm going to give are basically very primitive pipelines, and I'll illustrate how that works. But you're seeing pipeline architectures, especially the use of XProc, in a number of different XML databases in particular. MarkLogic includes it. EMC Documentums, XDB includes it. I think Exist is moving there. Okay.
Kurt?
Yeah.
Do you mind if I interrupt with a quick question?
Sure.
Isaac is asking, what's the relationship of pipelines to transactions? Now, you don't have to answer it if it's not pertinent to the discussion.
Actually, it's a good question. Okay. I think I've got a pipeline slide elsewhere, but I'll address it now. Pipelines are not transactions. Pipelines are basically, a good example of a pipeline architecture is something like Ant. Ant is, here is an XML file that basically says, do this, do this, do this, do this, do this. Transactions differ in that typically there is usually some kind of specific handshake that goes on. And typically you have an exchange of interaction between the parties involved in the transaction. In some respects they are similar, but I think the one difference that you run into with the pipeline is that the pipeline doesn't necessarily have the model of larger scale state and the ability to roll back that a pipeline does. So you can have databases that have transactional support, and it's, in fact, you're moving to a point where I know Exist does, I know Documentum's XDB does, I know that IBM does, where you can basically say, here are sets of operations that can run within the context of a transaction. But they're not quite the same thing. So think of a transaction as basically context or operation that can be rolled back. Okay, so anyway, getting back to this, XML databases will be the major platform for RESTful services. I do not doubt this at all. RESTful services and syndication. Syndication is very, very important. Syndication is probably the most important aspect I've seen to the web in the last 25 years. It makes it possible to use browsers and newsreaders to view, edit, and create rich documents. It provides notification of new content and updates. It can be used to populate AJAX-enabled widgets with linked resources. Syndication feeds can be aggregated and can be manipulated. The nice thing about syndication feeds is that they are basically collections of links with metadata attached to them. Because they are collections of links, you can basically work with these metadata bundles and link bundles, pulling in the resources as necessary to be able to do additional manipulation, but you don't have to. So I can do things like within Atom there's a category feed. I can use that as a filter for being able to filter only those things that happen to be in this particular category, coming in from these particular data sources, without actually having to go back and look at the full representation of the resource itself. So in a way, it's kind of like working with library cards rather than working with books. You can't get everything out of those, but if you need to get more information, you just follow the link. So this is where syndication has some incredible uses, and I see it as being very important when dealing with RESTful services. Atom is probably the first syndication format specifically designed around RESTful interfaces. Provides a way of representing the publishing aspects of collections. Syndication acts as the messaging architecture for updates and collections. So you can basically use it as, you can use Atom as a notification system to be able to say, hey, look, there's an update, check up here. Atom entries contain publishing information about a resource, as well as link summary and taxonomy, and can also be used as a transport mechanism for resources and collections of resources. If you're working with AtomPub, which is the Atom publishing protocol, then you can actually use Atom as a transport mechanism to be able to do things like creating feeds, creating entries within a feed. You're basically posting or putting content using Atom as a wrapper. Just as you would use it with SOAP, you're using Atom as basically a transport protocol. The advantage is that it basically maintains the metadata that you need about a particular object. And you can throw away the metadata that's not pertinent, but you have the metadata that you need as part of that transport protocol. You can also basically transport intermediate state objects to virtual collections and use that information within the content block or the summary block to be able to do the necessary modifications within that virtual context that you would be able to use otherwise. So you can think of RESTful services as a way, and it's not exclusively Atom, but you can extend AtomPub by recognizing that they can apply to any resources, not just to blogs. So when I talk about RESTful services, I can basically say, hey, I'm going to post an invoice just as if it were a blog. I'm going to get an invoice from this collection of invoices. And I'll give you some examples here in just a bit. It typically works over HTTP or HTTPS, but it can work over other protocols. And in fact, I've seen some interesting things done with AtomPub in sync with XMPP. Not sure if that's a typo. It's the Jabber protocol. Anyway, I think it's XMPP. I may be wrong. All right, so RESTful services and URLs, I'm almost done. A given collection, whether real or virtual, has an associated URL. We've talked about that before. The combination of URL and HTTP verb determines the service capabilities. A service does not need to expose all HTTP verbs. A virtual collection may only expose GET, for instance. So you don't necessarily need to expose publishing mechanisms, all of the publishing mechanisms, the put or post or delete, for a particular URL. You need only to expose one of them, maybe just GET or maybe just put. That's the beauty of this, is that you can basically say, I have a collection that's virtual, and I can only accept certain things. Everything else will basically go and say, nope, I don't want to accept this particular protocol. Okay, I'm going to run through these real fast because I know we're getting short of time and I want to run demos. In RESTful services, the GET protocol retrieves a sequence of 0 or more items from a collection. So one way of thinking about GET is that it actually always retrieves a collection, but that collection may have only one object. GET on a virtual collection performs an XQuery to filter, sort, and partition existing XML content. Retrieving a unique resource that involves performing a search with that resource's ID is a key. GET is idempotent. It should never change the state of the server. This is really important. This is the one break that you have from most XML RPCs. Most XML RPCs basically say, hey, we're going to use GET to change the state of the server. This is bad. You don't ever do that. We'll get into why, but it basically involves state management. Okay, post. In RESTful services, the post protocol adds a new resource to a collection, including a unique identifier. So when you do a post, it basically assigns a new internal URL to that particular resource. Post in a virtual collection basically performs an XQuery to add the appropriate resources into the real collections. So, for example, let's say that I'm talking about my medical record and I want to add a new lab report. I can post that into a virtual collection. And what that will do is it will not only add the lab report to the relevant lab report collections, but it will also add or create the necessary links elsewhere, so that it makes sure that you have the necessary bindings to say this particular lab report goes with this particular entity. So when you're dealing with posts, posts are not idempotent. They basically can change the state of things. I may have that turned around, but I'm not sure. Whatever. Anyway, posts can be used to add new real collection containers in some systems. So you can actually create collections using post. And it can be used to add queries to a query collection for virtual collections. I'm not going to get into that, but it's an intriguing concept. You can essentially expand your query mechanism, which is essentially the same. I'll get into that in a second. Put. The put command replaces one resource with another in the collection, updating the publishing information. It shouldn't be used to add new resources to a collection. As with post, put can work on virtual collections through a proxy object. And put can be used to update real collection containers or update searches for virtual collection containers. Delete obviously deletes it. Again, with some cases you can delete entire collections in the same mechanism. A lot of these are basically permissions based. Okay, head and discovery. Head is basically the mechanism used for doing discovery, and it's the only thing I won't be able to do a demo on. When it's applied to collections, it basically provides a way of telling you what services these particular collections happen to expose. It'll tell you what methods you can use. It'll basically tell you what faces that you can use, and I'll get into faces in a bit. It also can, in some cases, give you some idea about the interfaces. So if you're using query results with your interfaces, then you can basically go in and say, here is an open search template that will tell you the configuration of the queries. It can, for posts, retrieve expected schemas for the post output. So these will be the things that will validate against in order to be able to submit, and you can basically pull that in a way the same mechanism you have with WSDL, but in this case using an XSDL or an XSD schema document. It can also handle category namespaces for categorization. Okay, almost done. Get search and queries. While Get can be used to retrieve resources from real collections, it's usually used in virtual mode, as we discussed before. A Get on a virtual collection performs an XQuery on the data space and creates the output. Now, what that basically means is that when you're doing a Get, you're performing a query. Search parameters can be specified using something like an open search format as an example, then passed in as a query string as appropriate. So in this case, when you're talking about a query string, you're talking about a query string. You're talking about a mechanism to doing queries through that kind of a string interface. That means that you have one query through Get for one virtual collection. And there's a little bit of a definition, but that's one way of thinking about it. A virtual collection is basically a query, or a set of queries that are going to be tied in. The final piece that I've been working with is the notion of a face. A face is basically a transformation that takes a virtual collection and applies a transformation to render it out in such format, or into different formats. So for example, you can basically say, I'm going to take a collection and I want to render it as a table. Or I'm going to take a collection, I want to render it as summary blocks or teaser blocks, or I want to render it as an XForm, or I want to render it as an Atom feed, or I want to render it through a PDF processor and render it as a PDF document, as a report, as a graphic. You know, I can even modify outside that and say, well, I want to output it to JSON. Or I can render it out to SOAP. You know, all of these things are possible, but the faces layer is basically like the style layer used in a normal web page, in that it is a layer that is applied after the process of basically determining the initial query set. You do the queries, then you apply the faces or the transformation to it. Okay, I'll get into that in a little bit later, but in essence, when you're dealing with faces, you can do that in the request header as part of the query string or the services document itself. There's a services document that can basically act as the brains of this operation. Most faces are associated with transformations. Transformations themselves can be stored as resources. So, you know, the thing about all this is that you can actually pull in resources that do transformations that were stored as a separate collection of resources at some other point. Finally, faces also control MIME type of the output. What that basically means is that with the notion of the face, I can do something like, here is the MIME type for a KML document, for a Google Earth document, so that when you click on that link, the face that's exposed here will actually generate the KML document for showing up a Google Earth layer, for instance, or for creating an Atom piece that will actually be recognized as an Atom piece in its delivery content. So faces are very much associated with content type as well. Editors and XForms. XForms work very well with RESTful services. An editor is a specific virtual service itself. It is, in fact, a face. You can also use that in conjunction with pulled-in XML, so you can basically use editors that can retrieve internal XML content through a different face of the same service. All right, so wrapping things up, benefits of RESTful services. Once you move to a RESTful services model, it basically simplifies your APIs. Now, one of the big problems that we're running into is that we have more APIs than we even know what to do with. There are thousands of them out there. Every company out there wants to have its own API, and it's essentially lock-in all over. If you can move into a RESTful architecture, then the APIs become much, much simpler, because essentially all you're dealing with amounts to about 7 parameters when it comes right down to it. It works well with web browsers and AJAX components. It's link-centric with resource representations only loaded as needed. This is especially true with Atom. It can work with multiple disparate data streams regardless of origin. So you can basically say, I want to pull this from my XML database. I'm wanting to pull this from my SQL database with an XML XQuery front end. I want to pull this from a syndication feed, and I want to all tie these together. Now, that's the benefit of working with the RESTful services. It can actually integrate with SOAP WSDL services at certain junctures. I don't think that the two are completely disconnected interfaces. I do think that SOAP WSDL tends to work better in a transactional environment. We're talking about transactions again. WSDL tends to work better in transactional environments where you need to be able to have the context rolling back. Even that, though, I think is probably not going to be as true moving forward. Once we get XML databases up and running that have transactional support, then transactions become a little bit easier to be able to handle, at least at local levels. You're still dealing with orchestration, but and then it works well with pipeline architectures. Drawbacks. Security model is protocol dependent. You're basically dependent upon HTTPS if you're dealing with HTTP. Certain pieces, such as XProc, are still in the process of standardizing and getting accepted. So, things like pipelines are going to be important, but they're not quite there yet. You don't have a lot of standardization completely ready. I think XProc should be in the works probably by the end of this year at some point. Architecture, more database-like than traditional SOAs. So if you're used to working with SOAs, it can be something of a shock. There is no formal permissions model. That's very much implementation dependent. So you're basically dependent upon some. We need to still maintain some kind of permissions in order for that to be able to work more effectively. There is some issue of effectively doing data caching as well, and there are certain aspects where data caching can be something of an issue, although there are usually workarounds there. Also, it has an emphasis on XML technologies. If you don't like XML, then, well, it may not be the solution for you. So, final slide, RESTful Services projects. Now, all of these use some components or can be used for being able to do some kind of RESTful services. Many of them, as you can tell, are XML databases. IBM Lotus Connections was an interesting piece I saw last year at the SOA conference. And the funny thing is it is almost exactly this kind of model. They're missing a couple pieces, but not many. Windows Live Services is moving towards an AtomPub model. The new DocumentMX DB9 server is moving to this model. MarkLogic 4.0 server is definitely pipeline-oriented. And can be used in the RESTful architecture in this way. Exist Atom services, the Atom components are basically built. I've got an exist sample here, but that sample is basically run using my own custom RESTful pieces simply because I wanted to be able to illustrate them more effectively. Drupal is something that's worth looking at. It's not XML based, but a lot of the same concepts that I talked about here you can find directly in Drupal. In fact, Drupal was one of the big things in helping me to think about a lot of these issues in terms of the XML side. Orbion XForms has some pipeline architectures. Apache Abdera, ModAtom are both Atom projects, AtomPub projects. Atom Wiki works on the same thing. Atomic works on the same thing with Firefox on end. And that's pretty much it. So, after that, any questions before we go into the samples?
Hey, Kurt.
Hey.
That was quite an exhaustive presentation. So, one person was asking about HTTP head and said, I thought the HTTP, excuse me, I stumble over all these letters, head reply shouldn't carry any payload.
Yes, and that was one of the concerns I had when I put together that slide. There are actually a number of different discovery mechanisms that are used here or can be used here. And I put together head more from the standpoint of there usually does need to be some kind of a discovery mechanism in place. I use head somewhat illegally in that regard, but realistically, one of the best places to look is in the AtomPub specifications. They're actually dealing with some services-oriented, some RESTful services-oriented concepts, including discovery. I don't completely subscribe to the way that they're doing it, at least in the demos that I have here, because I think that once you start dealing with something beyond simply using it for blocking, other issues come up that aren't completely covered there. But one of the issues that you do need to do is a question of what's the best mechanism for discovery of services, and head is one particular example. But in a lot of cases, I think that we're still kind of coming to grips with what exactly, there's a lot of some standardization within certain aspects of RESTful services, but it's not by any means uniform yet. So let me leave it at that. Okay, any other questions?
Yes, James was asking, is a permissions model being considered at the standards body?
There is some talk within the AtomPub group, which is the group working with IETF. So Tim Bray and Sam Ruby and Leah Richardson and a few of the other people working in that particular venue. It's something that is being considered. Obviously, there are specifications out there. SAML being the one that comes to mind most obviously. But I'm not precisely sure at this stage where that is. I'd have to go back and look.
Okay, and Curtis is asking, and I would have to get some feedback on this. Curtis is asking if it's possible to go over the 90-minute time slot if we don't get a chance to go through all the demos. I know people are looking forward to that, but
okay.
But we do lose people quickly, though, when we go over the time. So
okay. Well, how close are we?
We have about 13 minutes, 14 minutes. So
okay. So I'm going to take one more question, then I'm going to go to the demos.
Actually, I think that was the last question that you haven't answered because
okay, well, let's
people have been jumping in and answering other questions. We've had a great group here.
Okay. So what I want to do is basically pull up. Okay. Can people see this?
Yeah.
Okay. So what I've done here is basically put together a very, very, very simple demo of a lot of what's going on. To give you an idea of the capabilities, what you're dealing with here is basically a listing. What I've done is I've created in the background a number of processes or a number of characters for a game. And this interface is running, there you can see it. I'm basically paging through respective entries in this particular game. Got 10 particular things. I can go in and look at a given entry, so I can go over here and I can view that entry, and here's the entry. Basically in a quick summary view, anyone who's played D&D in the last 20 years probably recognizes most of these terms. I can even go back in and create an edit view of that thing. Now this is using the XForms editor. That's part of Mozilla, but I could use other particular pieces. So I can go back here and I can do, let's go back up here. I'm going to say human bard, so we'll say make their intelligence a little bit higher. I can go back and update that. And I've now updated the particular character. I can go back. Now what I didn't do, it's kind of back and forward here. So now if I go back over here, I can go back here. I can view the character again. and I don't know if I caught or not.
And Kurt, one Zachary's asking if he could see the HTTP requests that are going on. Is that possible? Okay.
Yeah. No. In fact, I just wanted to give you a quick overview, and then I'm going to go into some more detail here.
Okay.
So, what I've done here is I've created basically a very, very simple system, and this is completely generated on my own. Most of this, when you get right down to it, is basically passed via these 7 parameters that you have down here. So here you have a collection. The collection has one of several different representations. So I've got this representation. I can go in and say I want it as, let's see, I want it as, what would it be, record. Oops, lowercase. I want it as record. So here's a record representation. Oops, there we go. So now this has changed that same information and is now viewing it as a series of records. I needed to make a minor change on some of my interfaces pieces here. Oops, I lost state again. No, I did this thing in about, oh, come on. Okay. So this is the same information that we had before, but this is actually looking from the URL standpoint. What you have here is a collection. In this case, a collection of characters. I can create additional collections, or I have created additional collections. I can change the face. So here is basically a change of face to a different representation, in this case an atom feed representation. So this is all basically coming off the same mechanism. Now, going back here, what you're dealing with is an interface where you can do things like saying, I'm wanting to do queries. So I can go in and say, give me, hold on a second.
Kurt? I think we lost Kurt's audio. Hey, Kurt?
Yeah.
Okay, I think we lost your audio for a sec.
Oh, no, I just, wait a second.
Put the phone down? Okay. You'll need to speak up just a bit, too. Thanks.
All right. Okay, so, no, this is not giving me what I wanted. Here, let's do, I can do things like this. Here's an entry matches entry name, and anything starting with C. Oh, no, the reason it didn't show up, I'm sorry, is because there are no entries. So I can do something like this. Starts with, let's try the letter D, since I don't think I had C's in my generated names. The back end is actually all generated, so I can say, give me all entry names that start with the letter D.
Hey, Kurt, they're asking what language you're using, what language your query was in. What?
The language that you're seeing this query in actually XQuery itself.
I'm sorry, I couldn't hear that. It's X what?
The language that you're dealing with here is actually a short piece of XQuery, or in this case, actually XPath too.
Short piece of XQuery.
So basically what I've done is I've queried this, and I've now gotten all things that begin with the letter D. I can minimize this and say, now give me all things that would begin with the expression DE. There happens to be none. So I can do, let's try DU, since I'm pretty sure that one did have a diphthong. Okay. I can actually create some fairly sophisticated queries. I'm going to put down fun 10. All right. So this now gives me all names that begin with DU that happen to be thieves. Now I can actually basically do anything that you would have within a predicate for an XPath expression through this. Sorting, I can do similarly. I can say, okay, now give me all of those sorted by, let's sort by alignment. Now, let's do people. Alignment's a little more complicated. Okay, so I'm going to sort by people in descending order. Okay, so what this has done is basically gone through and said, well, I'm going to go through humans, halflings, half-orcs, giving me all my pages. And some of this is causing me a bit of a hang, so I'm not sure what's up there. Okay. Let me show what's going on in the background here, because this whole idea.
And Kurt,
yeah.
Curtis was asking, did you mention what the data store is? He said he thinks that you alluded to it being generated. So was
yes, the data store. The data store is actually an exist database, and I'm going to show you a little bit more about what's going on there in just a second as I bring that up. I know we're running close on time, but okay. So what I'm dealing with here, first of all, let me just pull up. This is actually talking to the database itself. That location is the database. I can go back in here and I can say, let's pull up, hold on a second. All right. Now, after saying this is all simple, I'm sure I'm going to open these up and people are going to say, well, that doesn't look all that simple to me. Part of this is because what I've done is I've been putting together essentially the back-end service, and I'll show how most of this pulls together in just a second. So this pulls up. Service table, come on. Services, that's what I was looking for. Okay. So, here we go. In essence, what ends up happening, or what I ended up doing, is I created a services directory, or services document. The services document basically lets me define my collections, and I can basically define these in terms of what amount to a regular expression. So, for instance, I have down, let's see, I don't know where it went to. I had a match at some point. One of those. I did. I'll not get into it. But I can basically define a services expression that says, you know, here's a match all if you don't happen to find anything. This ties into a base collection, so there's actually a physical collection here that it utilizes to be able to provide the abstract. So the collection that you have here is in fact an abstract of the total collection that you're dealing with. It's the one that's forward-facing or public-facing. Within that, I can basically define certain methods. In fact, I'll go down to character because it's a little bit more clear what's going on. The methods in this case are matching specific HTTP verbs. Get in this case, post in this case, although one of the problems that you run into with certain implementations, and exist as one of them, is that sometimes the overriding or the underlying engine catches put and post and so forth before you do. There are ways of getting around that. I just didn't have time to implement them. So what this is doing here is it's actually handling my put interface, kind of kludely, but I originally had set this up to do a put, and it proceeded to overwrite the core function, the core script that I had, which is not what I wanted it to do, obviously. So in essence, what happens is that you assign to each particular collection a protocol to be able to be caught. And then within each protocol, you also define sets of pipelines. Each pipeline has an associated face with it. So there's one face per pipeline per protocol. The face, in turn, basically will say, okay, no, here's a record face. I have an edit face over here. I have an XML face over here. I have an Atom face over here. So when I'm doing a query and I'm saying I want a given face, then what happens is that it actually runs the pipeline that's associated with that particular face. Additionally, I can say here's a page size that I'm going to have for my records. So I have two collections, a characters collection and a character collection. The character collection will give me a page size of 15. I have a content type, which basically indicates the MIME type that this generates. So each pipeline has its associated MIME type. Atom here you can see is a different MIME type than for records table. You have then within the pipeline itself, you also have here an ID mechanism that can basically be used to identify the ID for particular operations. So in some cases, you actually have records stored internally that don't necessarily have user-generated IDs. So you need to have some mechanism to be able to reference them. This particular mechanism says, okay, utilize the internal ID to be able to retrieve that. And so when I ask for an ID, this is what will come back. And this is, in fact, a kind of form of query. Within each pipeline, then, you have additional steps. So here I have one step that performs a query. Now, this generates a table. I have this step that says, here's a query that performs an action, standard XQuery.xq. Gives a path to that action. So it's actually calling an XQuery script. It gives the default query. It gives the default sort arrangement. So in this case, it will automatically sort in an ascending fashion. And I can basically lock both the query and the sort mechanisms. So what that means is that I can basically say, this is accessible via a GET, or this is not accessible via a GET. Obviously, with some collections, you may not want to expose that XQuery capability, the ability to go in and say, I want to be able to modify the protocol. The standard XQuery script over here, or excuse me, the standard query script over here, let's see, is right here. Actually, let me step back just a bit. I know we're running over time, but I'll run through this pretty quickly. Okay, this is all run through serve.xq. And what this does is basically parses the services document. It does any of the parameterization coming from the URL. Notice that the URL can actually contain parameters even if it's not necessarily being used in a GET protocol. So, for example, you can post and still be able to pull from parameters in the URL. In this case, the parameters would be collection. If there is a mechanism that some databases are now beginning to use, or that some systems are using, where you can basically create clean URLs that would basically go in and say, okay, here is a base path. Anything after this path belongs to this particular parameter. So in essence, if I did that and I set this up to be able to do this, then my URLs would look something like XRX / characters. So my collections would actually be much cleaner in terms of the interfaces than they are right now. Again, it was just kind of a matter of I wanted to be able to get as much of this done. Most of the demo I did here was done in the last 3 or 4 days, so that was about as much as I could actually get done. You grab the faces the same way. This will basically do parsing to grab the services mode. All of these, if you're not familiar with this, these are all XQuery statements. So in some cases they're extensions, in other cases they're basically just retrieving content from the XQuery. This does the method match using regular expressions. This determines the media type from the pipeline. This basically determines the processor that you're going to be using, the action statement, and it'll either come off from the pipeline or from the method node where it has it. And then it basically does something that's a kludge. Sorry. The reason it's a kludge is because what it does is basically performs an eval statement on a script. If you had a regular pipeline architecture, then what this would actually do is it would run the pipeline, retrieve from there, and it wouldn't just be an eval. So there is some mechanism here. This actually will then walk through each of the pipeline steps depending upon what pulls in from the actions. So with serve, most of them are going to run through standard get.xq. Now, there's the function, or there's all that does. It basically runs this and walks through each particular element in the stack that you have. It retrieves that, looks at the node, looks at the actions. In my case, while I have those names don't actually mean much yet. You know, I may actually go back in and expand those out so that there is a difference between a query and a transform and the like. But for now, I didn't have any reason to put them in just yet. This retrieves the query filter that you had within the server block. So where's that? Okay. Why can't I find it? Standard services, there we go. Okay. So this basically looks over here and says, here's a query filter, or the query filter. Let's see if I'm going to go to query filter down here. Okay, so here's a query filter right here, actually. This will load in this particular query filter. If there's no query filter, then it basically retrieves everything in the collection. In this case, it'll basically automatically query. This should actually be locked. So this is actually used to query for a particular ID. From there, you do the same thing with a sort, retrieve the same thing for the ID, get the underlying base collection, and make these all basically visible as variables for each of the subordinate entries that are being called. And again, these would essentially in turn call the evaluated pieces, but again, these would be basically pipeline pieces. If I was running xproc, then this would be running a particular xproc pipe. So in this case, let's go back to services a second. The standard model up here is that this would go in for query and would then pull into the standard query function. So standard query is there. All right. So this retrieves the sequence of entries, performs a filter on it. So in essence, it runs the query that you pulled in either from the ID or from the query filter, basically creating a statement. So what you see here is a lot of eval statements within eval statements. Again, these are implementation specific things that would probably be hidden if I were pulling these from specific pipes. But I do the queries. Once I have the queries, I partition them. Here's sets of pages. Give them my page size, page sequence, generate a final sequence, and then I pass some messages on to additional pieces in the pipe so I can create new messages. The reason for the messages is basically that you're wanting to be able to pass information in such a way that you're not maintaining any more cross-platform state than is necessary. This in turn will get passed on to the next statement, which in this case is the rather unwieldy statement, character transform table. Now, this is probably the only downside to the whole process. You know, if you're thinking of it at a conceptual level, most of the time you're going to use that same standard query for 99% of the queries that you do. It's the individual pages, the output, that gets to be more complex. And those are going to be things that are going to be generated, or that are going to be essentially key to a given virtual collection. So in this case, this is key to the characters collection. It basically gets some, declares some namespaces, gets the, defines a couple of functions. These are just utility functions for working. And then handles, let's see, the definition of some basic properties. So this grabs properties. And then here it basically engine itself. It grabs through the sequence, separates it back out into the base sequence, which is basically the data, and the messages sequence, which is the information that you added previously. So the messages basically contain additional information that you may need for processing. Things like determining total count. You can't, once you do a query, you can't get, there's no clean way of being able to pass a total count of the number of items that are in that particular query result, short of doing some kind of a messaging architecture like this. So I pass in that information, and then I basically create the output. This is done here using XQuery. So these create the individual rows for the tables. So if I go back to the rows view, these are basically, or this is basically generated via this. And then the other piece is, this is then stored in a rows variable and passed in. So here I create a table. I add in the rows down here. So if there are no rows, and I put a warning up saying there's nothing there, otherwise put a character table, or otherwise put this new character table header and a few other wrapper elements around it. This, in turn, then generates also the output pages so that you can see the states of those particular variables. Now, obviously, on a normal page, you wouldn't see this. And then finally, this returns this table. That return content then gets passed all the way back up to serve.xq into the results variable. So all of that basically runs through, does these subordinate pieces, building up and building up the pieces in turn. It then serializes this, declares the option that basically sets the MIME type for the output, and outputs it, and that's it. So it looks complicated. Now there are some aspects here that I think are worth noting. Essentially, at any given point, what you're doing is you're passing sequences from one step to the next. So I've done a set of queries and a set of partitions. I've passed that sequence in. It's the only global variable in this particular context because it basically maintains the external context of the variables. So I've pulled that in here. I could, if this were not a terminating thing, I'd actually pass that on to another step. So I'd actually say, here's the output of this. Now pass that on as a sequence to the next step. Well, in this case, I don't have to. But normally, if I had additional steps, I could create these additional pipelines for doing processing beyond that. So I can do validation. I can do stuff like that. This could also be done, and I'm sure some of you will probably ask this, via some kind of an XSLT mechanism in some languages. So for example, Exist has a transform capability that lets you invoke an XSLT or XSLT2 processor. In that case, what you would do is you basically pass in, maybe wrapped, but you'd pass in the sequence as the first argument for the transformation. Then you'd run the transformation against it and pull in an XSLT from an external resource. And once you do that, then you can pull that information back out. Or take the resulting output and then pass that on as a sequence itself. So a lot of this basically becomes sequence manipulation. Now finally, the one advantage to this particular approach, or one of the advantages to this particular approach, approach is that by doing it this way, you can take advantage of the fact that you're dealing with streams or sequences of streams, and you can actually invoke them through external processes. Now here, for example, I'm actually retrieving the content. I've created a special component here which kind of hides it. And probably, looking back, I probably shouldn't have. But this actually passes in the character table reference and a few other things. And then the characters in the face that I want to be able to generate creates the view, outputs the view to a waiting div. I can actually even wrap this one step farther and say I'm going to just bundle this in as a binding into the element itself, and so you could actually create this as a binding. Now the advantage of that kind of approach, though, is that by changing just one piece, you can actually change a lot. You can actually go in. I'm going to say, let's take a subordinate piece that I had. So now when I out this and I look at the page, I go to bed test. Now it's just generating only the female entries rather than all of the entries.
Hey, Kurt.
All right. Yeah.
I think we're going to have to wrap it up. We're starting to lose the audience. People have to move on. But
well, actually, this is a good point to move on then, because I've got.
It's fascinating.
Oh, I did have one last thing I wanted to show very briefly.
Okay.
Okay. And that is that if I go and do this, I can say, let's do xserve, or excuse me, serve. So we're going to retrieve this content as an Atom feed. Now, it acts a little flaky sometimes, but now I can go to Google homepage and I can click on one of the entries, and it'll take me directly, except this one isn't working right. It should take me to one of the entries. I think I was futzing with it wrong. But I can also basically expand it out, and this will show up. Here I've actually dropped in the XML content into the summary block. So you could see this, you could actually output this as a report or some kind of output that you can then generate, and this will take you right back to the link. If I made a minor modification to that, and I'm not sure which one, this one, maybe that one. Let's try that one instead. But if I made a there we go. Okay, so the older one was wrong. Okay, so this actually will go back and do this. If I made a minor modification of the feed, I could actually set this up so that from Google I can see a list of the most recent entries, basically sort by date, and I click on it and it will bring me up the XForms page that will let me edit any content that I want to do. So for instance, if I wanted to say, here's a new invoice, I submit the invoice as part of the process, and that gets added to the queue, or gets added to the invoices queue. I can create a new new collection that would be pending invoices. That would look at just those that are current, that haven't been processed, and can actually process right from Google page. All right, so that's basically all I have, and I'm sorry for, I knew this was going to run a little long, but please.
That was extremely impressive, Kurt.
Well, thank you.
You've done a great job, and I know a lot of people are looking forward to your article, and I think they've named you the super uber geek or something for doing this. A lot of people are looking forward to your article on Friday, and I've let people know that once we have the URL, if you could send that to me, I can blast it out to everyone who registered for this, along with what else were you going to include?
Well, I'm going to include the slide deck, and I'm also going to include source code.
They want your code, yes.
Yeah.
Okay.
All right. Well, thank you, everyone. I wish I could actually listen to everyone else on the phone lines as well, but it's been fun. I hope it was useful for people.
It's been great. I hope we can have you back again soon, Kurt.
Thank you.
All right. Thanks, everyone. Goodbye.
Bye-bye.